So for those of you joining us, we're going to get started maybe in about a minute or two. If you're wondering why the Olympics music is playing, it's because we thought it'd be funny to have some background music. So I'm going to leave that playing for another minute or so. Just wait for stragglers to join us. All right. Welcome to folks that are joining us today. Thank you so much for meeting us in this session. This is a session that is going to run for an hour. It's called Human Computer Interaction and User Interface Design. It's hosted by me. My name is Tony Tang. I'm an associate professor at the University of Toronto. And my colleague, if you want to introduce yourself.
Hi, everyone. I'm Anastasia Kuzminic. I'm also a professor at the University of Toronto, doing research in human-computer interaction.
Great. And this is the second session today for INFOcon 2021. So hopefully you were involved yesterday and saw a couple of sessions there. And of course, just as a reminder to you, the sessions continue on through the day today and into tomorrow as well, basically for the whole day. So like if you aren't getting enough of school right now, you can continue to sign in from 8 to 5 o'clock Pacific time for another 8 hours of great content from different professors and faculty members in iSchools across, certainly across the North America. No, it also looks across the world. So that's really, really cool. If you joined the session just before this one, that was called UX and UI Design Careers, hosted by a colleague of ours, Mark Twiddale. Unfortunately, at least I didn't attend the previous one because I didn't register in time. So I'm not sure if Anastasia did. I have no idea how much of the content is going to overlap. However, I'm going to throw myself out there and just say that I think none of the content is going to go overlap, at least not really. Because ours is going to be way, way better. All right. So what's going to happen today is I'm going to give just a kind of a 20-minute kind of primer, if you will, on what we think about as user experience design, and not really talk about our program per se, but just kind of give you a hint about some of the things that you would be learning about and thinking about if you were part of an iSchool that had a user experience design program. Following that, Anastasia is going to do, can't remember if you wrote 27-minute talk.
Ish minutes, yeah, talk. And I'm going to show you how academic research informs design and show you how our studies might look like and things like that.
Great. So I think we are, I think we're open to questions through. So if you've got a burning question, even if it's not burning, but just kind of like a minor twitch, please pop up your hand or type something into chat. I can tell you as an instructor during these COVID times, it is excruciating talking to my computer screen and a bunch of icons. So if there's something I can talk at or respond to, that feels a lot better. So please feel free to ask questions at any time. We're more than happy to respond, and don't worry, we'll figure out how to make up that time a little bit later. Okay, so if there's nothing else, I think that's basically housekeeping. I'm just going to get going here and do the thing where I say, okay, let me share my screen and futz around with this until I figure it out here. So screen is sharing. We all see that? It's okay, Anastasia? Great. Okay, so this is the first thing that I like to share at the beginning of many of my classes. I think this is a hilarious example. So this is a story, actually now, each year it gets older and older, but this is a story from about 6 years ago now, I suppose. And the headline is Ford recalls SUVs because drivers are accidentally turning them off. And this is the console. I'd like you to take a look at this and to try to think about what's going on here. What's going on that makes drivers actually accidentally turn this SUV off? And I will give, I don't know, a virtual high five to the first person that can figure this out really, really quickly. So I'm going to give you, I don't know, 10 seconds of awkward silence. If you think you've got it, feel free to populate that in the chat. In the meantime, I'll stare at you quietly. Okay, that is far more awkward in real life than it is quietly in my office. So I'm going to assume that you may have figured this out or you may not have, but I'm going to kind of walk you through what's going on here. So this is the console dash, right? So this is where you would play with your radio and stuff like that for a car. And one of the things that they did in this SUV was they were being very innovative and decided, instead of having any sort of stick shift control to go from parking to reverse to neutral and so on, they decided to make them into buttons along here. So you can see parking, reverse, neutral, drive, and this is the sport setting. Not quite sure what the sport setting does, but that's the sport setting right there. And underneath, you'll notice right here, this is the engine start stop button. And so what was happening with this vehicle is that the start stop button was right there. And people were essentially, when they were kind of reaching over, they were driving, they're like, oh, I need some sport mode here. They'd reach over, hit the button to try to start sport mode, but they weren't looking because they'd be looking up there, and or their finger would slip, and then they would actually turn their car off while people were out driving the vehicle, which is, if you can think about situations where you might be wanting to switch into sport mode, kind of dangerous, right? And so, you know, for me, as somebody who thinks about user experience design, who thinks about these experiences that we're designing for people, I actually think that for me, I'm actually, you know, I'm a little offended by the title here, because I think this title of this article, as perhaps descriptive as it may be, actually ascribes the blame to people who are driving the car, right? It ascribes the blame to drivers. But to me, this is actually a design problem. So if I were redesigning this title, what I would say is Ford recalls SUVs because poor user experience is creating dangerous situations. Because to me, the fault should lie in the people that designed this thing, not so much the people that are driving the cars. So the title of this talk is called The Primer on User Experience Design and Human-Computer Interaction. What I'm going to do today is spend a lot of time talking about these little examples, these toy examples that I've seen in everyday life, and talk about how I think they kind of help us to understand why certain experiences are designed poorly and what they say about how we should design things, objects, tools, or things that people use in better ways. So to me, bad design is absolutely everywhere. And in fact, one of the bad things about kind of doing a program in user experience design is that you learn about what good design ought to be. And so all you see in everyday life is how everything is terrible. On the left there, if you are a guy that uses public washrooms, you'll understand why this is a challenge. If you are not, then I will describe the situation. Essentially, this would be a very uncomfortable urinal situation to use to pee in, particularly if there was somebody else who was thinking about peeing next to you, really needed to go. It's just ultimately not a lot of space. The example on the right is also a bathroom example. This is essentially an automatic faucet. And essentially, this is a situation where they decided to put up a sign because it wasn't clear how to use this thing, right? So it tells you that it's an automatic faucet. It explains to you that to turn it on, you need to walk up to the sink. And to turn it off, you walk away from the sink. So don't worry, this thing is going to turn itself off. I think the other thing, so, you know, here's a sign that tries to explain how to use the thing, right? I think the other thing that's really interesting about this example is that it says black clothing does not operate faucets. And as a former engineer in a previous version of my life, I can understand why that would be the case, but this is just horrible, right? So if I'm wearing black clothes, like it doesn't work. But actually, if you kind of tease apart the language there, it doesn't make a lot of sense either, because to turn on and off, you walk up and back, but the clothes don't do that. So anyway, I think these are examples of poor user experience designs. I'm going to show you this video that I watched. This is Munchies. This is a food YouTube channel that I like to watch. Anyway, I just saw this clip the other day. I thought it was really funny and kind of on point. You will not be able to hear the audio, but what I'd like you to do is to focus on this person right here and to think about what's going to happen as she tries to go through that door there. Okay. So if you are like me, if you are like her, you have been in these kinds of situations before where you're trying to go through a door and for some reason it doesn't work quite the way you expect. These are tiny little moments in your life, but if you accumulate all those tiny moments across your life and across all of the people's lives that will go through that door, you can kind of start to tally up how many instances of displeasure this causes and potentially how much time this wastes. And potentially, maybe how much food is wasted as they kind of exit this place. So what's happening, of course, here is that as she's trying to leave, she tries to push the door and it doesn't work. And everybody's laughing at her and it's really funny. But if you think about what she's doing actually makes perfect sense. This type of handle is the push handle. She is doing the right thing, or at least the way that the object is telling her to do it. She is doing the right thing. And so when it doesn't work, it's kind of weird. You'll notice on the other side of the door, that's the side of the door that we're sitting on, we actually see this handle right here, which is a pull handle. There's no question about it. This is the pull handle. And of course, here again is a sign that is written there that says, oh, from here, you need to push. And so a couple of insights here. One is that often when you see a sign, it's because the tool itself or the object itself is not doing a good enough job of explaining exactly how the thing ought to be used. And so people that use the environment are like, oh, I guess we got to explain kind of how it's working here or how it's supposed to work, right? Okay, so I feel like I'm definitely doing the prof thing of just belaboring these kind of ridiculous little examples. And so if you don't enjoy that, then now's the time to sign out. Otherwise, I'm going to keep going on these kind of ridiculous little symbols or these ridiculous little examples. This is in the sort of academic context, this is what we call a signifier. So the way in which the door handle is shaped is a signifier, and it signifies a particular way of interacting with the thing. And what we would say here is that the design problem is that the signifier is actually misleading. It doesn't actually inform the person on how to use it properly. And you'll know as a person that goes through doors, you're not actively thinking about this. It's almost unconscious. You're just like, oh, that handle, okay, this is the kind of thing I do. But that's exactly the moment where the signifiers matter, right? So choosing the right signifiers in the right moment for the right place is a really, really important problem. I was going through some old slide decks the other day, and I realized that this example, which I like to show, is now truly a classic example from my childhood. And I'm curious how many people have any idea what this is. And if you don't, it's not a big deal. I'll walk you through this. If you do, then you know exactly what I'm talking about. Okay, so this used to be the back of most computers, okay? And this is kind of a little bit hard to explain without having like a computer in front of me. But essentially the top part of the image, the part that has these two little black plugs, is kind of like upright. And then the bottom part of the image where there's a green and an orange icon, it's sideways like this. So you can imagine that the two black things are kind of up here and down here. I'm trying to show this in my little video here, but my book is all blurred out. But anyway, black, and then green and red. So these two plugs are called PS2 plugs, not PlayStation 2. I can't remember what PS2 actually stands for. But anyway, they were for your keyboard and for your mouse. And they are the exact same plug, right? So our mouse, this is back in the day of wired peripherals, and we didn't have USB yet, right? And so we plug these two things into our computer. Part of the problem is that usually it's behind the computer, so you couldn't see the back of the computer. But anyway, even if you could see the computer, the back of the computer, one of the problems is you weren't sure which one to plug it into, right? You can see one of them is meant for the mouse, one of them is meant for the keyboard. And what I can tell you is the problem with this interface is that it's not clear whether the green thing matches up with this green thing matches up with the top green thing, or whether it matches up with this green thing. And because you can kind of easily imagine that two different kind of ways to think about this. Maybe these two icons go like that, and so they just kind of, you know, flip up like that, or it's kind of this mirror situation, because you've also seen that too, where this thing matches up kind of like that, sort of like it's a mirror type of a situation. So these are the kinds of very simple versions of the problems that we deal with in user experience design. And I would argue that these two solutions that you can see on the right addresses this problem. This is what we call a mapping problem. So how do people map, you know, one particular series of things to another series of inputs? So here's one solution. If you simply put the icons next to the thing that they were supposed to plug into, that would be very clear what to do. Similarly, if you simply kind of use some color coding to support that mapping, that would also help a lot. And so these are kind of simple concepts that we kind of visit and revisit again when we're kind of doing user experience design and when we're doing human-computer interaction research in the lab. So I want to invite a response or two on what you think this is. I can tell you that this is something I took a picture of when I was on a trip. So I'm interested to hear what people might imagine this would have been an image of. I was on a vacation, I think. So anything goes. Jill, excellent. Elevator buttons, gold star for you. And I see Moises responded a little earlier. Jill and Nicole, gold stars for both of you. These are elevator buttons. What is, okay, fine, Jen, you also get a gold star. Let's give it a silver star with that Olympic theme, Olympic medal, or silver medal Olympic theme. Okay, anyway, so these are indeed elevator buttons. What I want to ask you now is to think about why, like what makes this set of elevator buttons maybe so special? What's so cool about what's going on here? Ah, yes. Okay. I see a response here. I'm sorry, I'm not quite sure how to pronounce that name, but yes, there's Braille on here. So Braille is a way of allowing, helping people that can't see that well to read things, right? And so you can see here that there is Braille on each of these elevator buttons. What's really neat about it is Braille is basically these like little raised bumps that you can run your finger over, and that allows you to kind of like read text. It allows you to render characters and letters and stuff like this. So the reason I took a picture of this was it looks kind of cool. So this is some like hyper doodad elevator where when you walk in, you don't see anything, but as the elevator door closes, this cool like projection thing happens on the wall. And so these like elevator numbers actually start to get projected. So kind of, and then you can kind of see. This is a touch sensitive elevator. So when you touch things, it activates things. So this is, okay, again, maybe about 5-10 years ago. So it's really, really cool. And so you could, in fact, and so this whole wall is basically a touch sensitive wall. What is ridiculous about this? So hopefully at this point, you might be able to see what the problem here is, right? So it's a touch sensitive wall, which is super cool. On the other hand, and it's also super cool that they're embedding some Braille into the environment so that people that can't see that well, right, people who have vision deficit challenges, they can also use the elevator as well by using Braille. But therein lies the challenge, of course. If I am a person that needs to use Braille to read the elevator, to read which buttons I'm supposed to press, I'm probably activating every single button by running my finger over each of these Braille buttons. So this is an instance where I would say the heart is in the right place, but the execution is a little bit lacking. To me, this is what I would call sort of an obvious problem in hindsight. But the real problem is that often the designers that are actually making the systems, they often aren't the ones that are using them. And so often they make assumptions about how the systems are going to be used. And so one of the things that we do in user experience design research and user experience design is we build empathy tools to try to understand who our users are. And so in this case, one of the things that you would say is like, okay, well, if you were to do this a little bit better, what you would do is you'd put on goggles that make your vision kind of foggy and to try to learn how to read Braille and to try to experience what that elevator would feel like. That's something we call an empathy tool. The other technique, of course, is that we use prototyping. So we build things, we mock things up, and then we test the designs to see if we can uncover new problems that we hadn't anticipated before. So we actually would give it to a set of people to test out as a pretend elevator. We would try to find people that we're trying to tackle with this system. So if we were doing it for an office space, fine, find some office workers. If we were trying to support blind users or people that have low vision, then we would find some of those people and have them test out this elevator interface, and just to see kind of how they experience this interface. Oops. So let's move on here. I think this is a really important idea, this notion that often designers aren't the ones that are using the systems. Here's an example. I think I took this screenshot maybe about 5 years ago or something like that from my Windows PC. I turned it on one day and then like both of these things popped up. I'm a computer scientist by training, so I have some sense of what some of this language means. But I can tell you that even in this moment, so I was like, oh, I'll do the right thing. I'll hit this update now button, right? So like, as opposed to the notify me later, except for never notify me because I never want to be bothered about it. So I was doing what I thought was the right thing. And then this thing popped up. And it was a really interesting moment where I was like, actually, right now, I'm not sure what I'm supposed to do. Because what I did was I told the system like, hey, get the new drivers and sure, fine, scan my hardware, do whatever you're supposed to do. This is like maintenance stuff, right? And then down here, it says, okay, update the system BIOS, and my system's going to restart, and I should close all the open documents and exit all the running applications. Don't interrupt the procedure once it begins. Don't just, like, this sounds really, really serious. And I can tell you as somebody who kind of like grew up around computers, like I said, computer scientist by training, like even this gave me a moment, even for me, this gave me a moment to pause. So I was like, wait, which of these things should I be doing here? I'm actually not really, really sure. And then if you think about this, what would that experience be like for somebody who isn't a computer scientist, who doesn't know what all of these words mean? Like, what the heck does BIOS mean? Or is it even pronounced BIOS? Maybe it's pronounced BIOS, right? Do not interrupt, do not disconnect. These are really, really sounds like really serious things, and they're scary sounding. And I think one of the things that we want to try to do when we build systems for people to use, build tools for people to use, build experiences for people to use, is we want to make it so that it is a friction-free experience as best we can. We want to make it so that it is smooth. We want to make it so that they're not scared about the consequences of taking one action or another. And so if you, maybe you don't have to imagine, maybe you've lived this experience. If you imagine yourself seeing this and you have these two options, install now or remind me later, probably what you're going to do is hit remind me later. And if you think about all the reminder me laters that you've done on your own computer, and I certainly cop to doing it all the time myself, there's a ton of things that my computer needs to do that I never wanted to interrupt me to do because I don't know what the consequences might be. And so this is the reason why so many computers are left not updated or vulnerable to, all sorts of malware and stuff like that, because, we in practical reason just ignore these things because we're not quite sure what the consequences are. And I see Jen has contributed a quick comment where, yeah, you understand what a BIOS is, but even then, this is quite confusing, right? Just another example, just while we're at it. Right, so I told you that once you start to learn this stuff, everything starts to look terrible. But even if you haven't learned this stuff, you can probably see this thing is pretty terrible. This is, I took this in Washington, D.C. This, I believe, is, like you get a ticket to use the subway with this machine. And I think if you use this all the time, no big deal. But I can tell you as the first time using this thing, this is absolutely absurd. If you think about how reading works in North America, normally you start reading from up here, right? Top left, you move right and then you go down. Here, the system is actually telling you, okay, look at the instructions. And then over here, in the middle, there's this big loud thing that says, this machine gives change in coins only, right? It's super loud, right? And then there are numbers that tell you to look at these different things, like insert ticket here. Okay, that's number 1. And then also insert validation. But wait, does number 2 mean insert coins? And then how do I use this thing? And when do I do this? Oh, shoot, there's an insert cash button over here. So maybe like, presumably these are exclusive. And then you can see take receipt is down here on the bottom left. And also don't forget to take your change. So there's a ton of things that are going on here. And if you think about the engineering that is required to sort of make a machine like this happen, you can kind of understand like different pieces, parts of it are made at different times and stuff like this. But really, if you're thinking about the user experience of this machine, I mean, it's awful, right? Like, where do I start? Where do I end? Hopefully, the way you do it is you start from the top left and kind of move to the bottom right and everything gets done. But I can tell you that this is, in my view, sort of a hopeless interface, kind of in a walk up and use kind of situation. Okay, I'm obviously overstating the case. I was able to get my ticket and stuff like that. But of course that takes time. That takes whatever, 5 minutes of my time. And that's a real problem. 5 minutes of my time means the guy behind me is waiting for me and getting angry at me. Okay, so I'm just going to show you a couple other examples. Anastasia, I apologize. I said 20 minutes. I think I'm going to be 25. It's okay. So you can, you don't have to. Okay, so anyway, I'm just having too much fun kind of complaining about the world that I live in. This is, okay, so I'm realizing now this may be a function of, being trained in user experience design. It could also be a function of the sort of being like an old man and just kind of complaining about how the way, how the world is and how it could be better, right? Okay, so this is a kind of device that we're all becoming very accustomed with, right? A self-checkout machine. And I'm like, you know what? I'm a savvy young man. I can use these things. I don't need to, read instructions. So I come up to this thing and you can see here, I was buying, this is carpet shampoo and an extension cable. That detail is not important for this story. Okay, so basically I'm like, okay, so I know how to use this thing. Like you just, start, run the thing over and hit beep. Okay, so I like pick up the thing and no beep. And so I'm like, okay, that's kind of annoying. So I see this sign that says, okay, please press scanning to start beginning your transaction. Okay, great. And I look down here, okay, please press start. This is in Canada, so we need to have start in English and start in French. I speak English primarily, so I hit the start button. And now I'm like, okay, good, I'm good to go. And I try to do it again. When I try to do it again, it still doesn't work. And then this is the moment where I decided to take a picture. So you can see here that there's a sign here that says, please press start scanning to begin your transaction. So I have to press this button as well, start scanning. And you might be saying, hey, didn't you already press start? And the answer to that question is yes, I pressed start 2 times. I started twice before I was even allowed to start scanning. This is, again, a minor hiccup, but enough to kind of like, make me annoyed, right? So this is, so the lesson here is that signs, literally written signs, and I think I said this earlier, are often a sign that the customer journey is unclear. It's not clear what a person should do about this. I'll show you one other example. This is from a while back. So signifiers and signs can also be shapes of things. I'll play the video and just explain simply that this was me I was on a date. So I was trying to like, make a good impression. And she was, yeah, anyway, so I'll just play the video. Yeah, centered inside, everything's good. Oh. So once again, oh. Okay. So actually that means that you need to use 2 hands to use this thing.
Well, actually, you can push it with this,
Like
but nobody
this?
does that. So you can push this here,
Oh,
but nobody can figure that out.
right. Well, okay, good. Okay, so when I said okay, that was the moment that I realized she thinks I'm an income poop and I'm never going out with this woman again. Actually, everything ended fine. But for the purpose of this story, the thing I want to point out is that this thing is shaped in a convex way. So it bubbles outwards. And my argument here is that if it was bubbled inwards, so sort of the shape of the indentation of a cup, then it would have been much clearer how to use this thing, okay? And here's some other examples where it's good. Here, I just wanted to point out that, sometimes we've all encountered this kind of thing where it's like opt in, opt out, who knows what I'm trying to do. And the fact that there's a long description, who knows what that means. Sometimes my argument is that we call these things dark patterns because they're designed intentionally to mislead users. So lots of interesting stuff in user experience design. I know you might be thinking to yourself, look, I'm not going to make that mistake. But the thing is that you are typically not your user. You have your own biases and blind spots, and you are working on a team. And so it's important to learn about techniques that help you to kind of arrive at better designs. There's a bunch of user experience and HCI jobs that you can get out there. And they have all sorts of different names. So the typical joke is you can pick one of these things on the left column here and combine it with something on the right column. And boom, there you have some sort of user experience job, right? So you can be a usability analyst, you could be a usability engineer or developer, you can be an interaction designer or usability interaction engineer. So here's the quick summary of my 30-minute talk. Design is everywhere. Objects that you use, web systems that you make use of, tools, apps, physical environments, libraries, signs in the libraries, reports that you build. Good design is hard. It's not easy. Poorly designed things have big consequences. They're annoying to use. And when you learn good design practices as you would in a user experience design program, you can help make better designs. So here's a quick thing, some contact info for me. I'm happy to answer questions if you want to reach out. And I'm definitely 10 minutes over my time, so I apologize, Anastasia. I'm happy to hand the baton over to you.
Okay, just give me a second. Can you see my screen? Okay, going in chat here. Okay, hello everyone. I'm Anastasia, and Tony showed you a lot of examples of bad design. And the reason why we started this session was this part, because indeed it's our highest priority, right? To learn how to avoid mistakes. But another facet of our work is designing novel technology and understanding of what is needed. So how to develop these truly new types of devices, software, and other technology often comes from academic research. And so what I want to do today, I want to give you a glimpse of how it might look like on the example of some of my work. So I'm a researcher in HCI, as I mentioned earlier, and my work in HCI covers a rather broad range of research, from development of different interaction techniques through creating multi-device ecosystems when we use different technology within it, to informing architecture of computer vision, and so on. And at some point, I became fascinated by this idea that we've got two really intelligent, powerful entities, a human and a computer. And what we're trying to do, we're trying to put them together to make them talk to each other so that they can accomplish a richer set of tasks, right? And optimize what each is capable of. And yet developing this communication between humans and computers is really complicated. And it keeps being surprisingly challenging throughout our whole story of our field. And if originally in 80s, when HCI was just starting, HCI as a field was mainly concerned with how to make computers so that humans can understand them, then now, especially with the development of machine intelligence, the question is shifting to how to make humans and computers to understand each other. And so on one hand, it becomes more and more clear to all of us that our ability to create a partnership between humans and computers and integrate computers into natural communication is going to define what we as a society are going to be able to accomplish. But on the other hand, we learn again and again that building this successful communication, even just between humans, let alone humans and computers, is very challenging. So think about all the complaints we have heard during the last year and a half about the system-supported communication and learning, right? For instance, learning through Zoom. So in my work, I study the mechanisms of this mediated communication. And more specifically, I explore this dynamic context that moderates, mediates, defines how we explore information, how we share information, how we perceive information in these different types of communication. So why context and why information? Well, because understanding what we as humans do and why we do it, and understanding what's going on with us, depends on understanding our current context. So for computers to become human collaborators in communication, they need to learn how to understand and even reproduce this context. And because communication in its core is an exchange of information, the system's ability to work with people requires understanding of how, why, and when people share and don't share. Because no matter what, systems performance depends on information. And for the same information, we as humans, we're ready to share or perceive it in one context, and we're completely against doing it in another context. So today I want to talk to you about some of the aspects of this design for systems that aim to support this communication, both between humans, right? So human to human communication and human computer communication. And how to have these systems context aware. So how to make them so that they can adapt their functionality and their behavior to the context and why it even matters to us. So first, let's think about what is communication. And more specifically, what's the difference between interaction and communication? Any thoughts? It's actually a very complicated question. So I'm going to just, for the sake of time, I'm just going to jump in towards the answer. So if we think about what is interaction and communication, in both cases, it's an exchange of information between several parties, right? So it's always an exchange of information, and there are always at least two parties involved. But in fact, communication is a subtype of interaction. And interaction becomes communication when we start thinking that the other side has some capacity to act independently. So when you start thinking that the other side can make its own choices, you suddenly start communicating instead of just purely interacting. So maybe you have seen those funny videos when an elevator is voice operated, and then elevator doesn't understand people, and people start yelling at it, talking to it, saying that is, making fun of them. So that is the moment when you shift from interaction to communication. And so now, with the development of this machine intelligence, with machines becoming this communication actor instead of just an interaction actor, now we can view these systems as forming a continuum from communicating through technology, such as Zoom, for instance, Skype, different social networks. So when people interact to each other through this system, to communicating around technology, such as monitoring systems, large multi-user displays, collaborative software, to communicating directly with technology, such as different conversational agents, robots, and so on, like Alexa, Google Assistant, and so on. And so in my research, I look at how, depending on the place on this continuum, these systems have different contributions that they can make to the communication process. And so that is how we inform design from the research perspective to the actual product design. So let's first look at the interaction through the systems. For example, teleconferencing systems, or let's say social networks. They're designed to be a platform for communicating with other people. But because this communication is mediated, the users often don't have the full picture of who is on the other side. So for instance, who is reading our posts? Who can see and hear us on the screen? Let's say right now I'm on your screen. I have no idea who is around you, what's going on there. I have no idea how you're reacting to what I'm saying, right? So I do not have this full picture about you. And so since I do not have it, and people do not have it, we create something, like some kind of conceptualization of who is on the other side, something that we call the imagined audiences. And of course, what we imagine is often very different from the reality. And you could say, so what? Why does it matter? Well, it matters, first of all, because our imagined audiences, so these ideas of who is on the other side, determine how and what we communicate to the real people out there. But it also defines our expectations on how the information is going to be used and perceived. So you can think of all the issues around privacy, about oversharing, about misunderstandings in communication, the efficiency of communication. So all of that has to be supported by these systems. And so because of that, we show, for instance, with my colleagues, that the role of technologies through which this communication is happening, so these technologies on the left side of the continuum, their role becomes to gather this missing contextual information about the audience and to integrate it into the communication in a suitable way, which doesn't necessarily mean, of course, to just spit it out to the user, right? No, we need to be smart about it, and we can develop different features that would support this communication based on this contextual information. For example, online forums as one of the situations of communicating through the technology. How can we integrate the missing information about the audience into the communication process here? Or for example, we can present some information about the person, right? We can say how many posts they made, with response to what message they're posting their answer right now. We can show if they have some special status on this forum, right? For instance, if they are an administrator or something like that. So that is an example of how this information can be embedded into the communication. Information that we can gather and then embed in the process through the design. In other examples, on social media, for instance, when you can define who is going to see your posts, right? Or let's say stories in Instagram, you can see who watched it, right? But if you think about your experience of using these systems, think about what doesn't really translate there. What is there when you're using, let's say, Facebook, that doesn't really, that you would want to know about your audience, but that is not supported through the design. And let's say Facebook researchers, who are like more academic researchers, that's the way how they're thinking about these problems, right? They go there and they start exploring what else is that is missing. And based on that, new features are being developed. Same with Zoom, right? For instance, what we're doing right now, as I said, let's say I have no idea what's going on with you right now there. And even if everybody would have their videos on, there is still a lot of this context about audience that is missing. Okay, so when we communicate through the system needs to gather and integrate this information into communication. And now if we move to the right on the continuum, so to the middle, we would find here the systems that are mainly augmenting this ability of users to access and produce the information. So these are the systems around which we're communicating. So the examples of such systems can include, for instance, public displays, right, or digital tabletops, and they provoke these spatial interactions around them. Or it can be software, for instance, different like Mira board, right, or Google Docs that you share. And so software provokes the interactions around content that they provide or help us to create. So what do you think matters in this case? What should the technology be doing to support this type of communication? So because these systems in the middle are mainly augmenting this ability to access and produce information, their main role becomes to provide this information in the best, most contextually suitable form. And what exactly it means depends a little bit on the type of the system. For example, for the, let's say, large displays, right, or some physical systems, this includes being able to adapt for, let's say, collaborative or competitive scenarios, right, or adapt for the territoriality and proxemics around the device. So proxemics is a field of the study that is concerned with the way how people organize their space, their territory. And the term was suggested, and the whole field was started by Edward Hall, who was a cultural anthropologist. And what he suggested is that there are these 4 circles that exist around people. And the closest one is this intimate space, then personal space, then social space, and then public space. And depending on your relationship with people, you're going to be standing on the appropriate distance between yourself. So why does it matter to us? Well, for example, when you're presenting information to the situation, like let's say to an intimate couple, right, or to a family, you can support this more intimate distance between people. But let's say for the work situation, you have to present information so that it would be within these appropriate distances as well, right? With software, so that's for physical systems. With software, things become slightly more complicated. But let's look at the example of software for co-watching movies and videos. So in this case, people are communicating here around the content that this software provides, right? So what do these systems do to provide information in a suitable format? Any ideas? Anything goes. On top, right? What do you mean on top? Overlay on top. Yeah, so the fact that the chat is on the side, right? So the focus is on the main content for sure. You can see, for instance, here who paused the video, right? If somebody stops the video, it stops for everyone. So the fact that chat is on the side, yeah, so that the content is on the left. So there are a lot of aspects within it that you see here. We're not focusing, as let's say in the forums, on providing this information about the audience. Instead, we're focusing on the action, right? And we're providing information in this suitable format. Okay, so far we have discussed that when we interact through this system, these systems should be gathering and integrating this missing context into the communication. When we interact around technologies, their role is to understand this context and provide the information in contextually suitable format. And now let's look at what is happening when the interaction is taking place, communication is taking place with the technology itself. And so the systems on the right end of the spectrum are built around the idea of intelligent agents. And this includes, for instance, chatbots, voice-activated assistants, different types of robots, social drones, and so on. And since the communication here happens with this intelligent agent, the systems tend to be heavily anthropomorphized. What is anthropomorphization? It's when we start attributing lifelike, human-like qualities to something that is not actually alive. And in fact, that is an evolutionary adaptation. That is something that happens naturally, mindlessly with people. And that helps us to make sense of something that is complex, right? So that is the true moment when we're moving to the communication with the computer system from the pure interaction. That is the moment when a computer stops being a pure tool and becomes a communication actor. So how do you think it would affect the role and responsibility in this collaboration with humans? Well, arguably, the responsibility of this technology is then to be a good communicator, right? To be a good communicator partner, which includes both this ability to recognize this user's communication context and to match this context in communication with the user. So from the system development perspective, it's two different sides. One thing is to understand what's going on, and another thing is to reproduce this context in communication. And this I will show you on the example of one of my studies with conversational agents to show you how this academic research can inform the actual product design. So the general purpose voice assistants, such as Alexa, Google Assistant, or Siri, for example, they're becoming more and more popular, as you might know. And so more and more users are interacting with them on a daily basis. And these systems, in essence, rely on users' voice interactions with a persona or an agent who is deliberately designed to speak and act human-like. And because of this, these voice assistants end up being integrated in both technological space of a user's life, so the ecosystem of devices in their life, and at the same time in their social space, so with whom our users communicate on a daily basis. And so they tend to be anthropomorphized, right? So again, people start attributing this lifelike qualities and traits to these agents. For example, users flirt with them, which in fact became so common that now in popular media, people joke and make movies about it. So maybe you've seen there was a movie called Her, or there was an episode on the Big Bang Theory at some point about that. Or as on this image on this slide right now, hey Siri, Siri says, we need to talk. Who is this Alexa person you keep flirting with, right? So it became a real social thing. And you could say, well, that's cute, but so what? Why does it matter to us? Well, it matters because anthropomorphization and these processes heavily define the interaction style, so how we talk to this system, and also users' expectations, trust into the system, and even use cases with this technology when people adopt these systems. And yet we know very little about what happens when anthropomorphization occurs, right? So do we see, let's say, all agents as the same type of a person in this case? Well, intuitively, probably not, right? But if not, does it depend on us, how we perceive them, or on the design of the agent? So let's say, would it differ between how I perceive the same agent and you, right? Would it depend on the user, or would we perceive the same agent the same way, right? So we didn't know that before. And so what we did know before is that when we talk about anthropomorphization, there are kind of two sides to it. One side is that there is this behavioral design. So that is emotional responsiveness, the way how, with robots, for instance, the way they move, how warm they are in their interactions, their personality, and so on. And on the other side, there is this physical or visual aspects of it. So let's say facial expressions or body expressions. So your Roomba vacuum would have only behavioral traits, only the way it moves. And then your, like a wax sculpture, for instance, would have only visual ones. And so by design, of course, voice assistants are capable of displaying mainly these behavioral aspects, right? The way how they act and talk to you. But what personality and behavioral aspects, what aspects of this talking matter to users? And is there any structure there? Do we think about them in the same way or no? And so we thought that if there is any structure there, then these perceptions should be consistently different for different agents, right? So let's ask a lot of people about how they perceive the several agents and see whether there are patterns there. And we also thought that if there is some structure there, then the way how people think about this personality of an agent would also define how users visualize this agent. So how users think these agents would look like if they were humans. And especially because agents answer can include some visual references, like for instance, Siri's "I'd blush if I could," right? Or I think it was Google's "I would hug you if I would have hands," right? So then if there are consistent differences with the way how they act, then there should be consistent differences with the way how they are visualized as well. And the only way how we could look at it was to compare several agents. So we took 3 agents, Alexa, Google Home, and Siri, and we first asked people to interact with them, to talk for a little bit. And then we interviewed people. So we talked to the participants, and we asked them, what are if these agents would be humans, what would they be like? What are their definitive characteristics? And then as a third step, we also asked people to create these visualizations for each of the agents. So what did we learn there? So the main highlight about the perception of the character is that they're indeed structured, these perceptions, and they're structured according 5 categories of personality: approachability, sentiment towards the user, professionalism, intelligence, and individuality. So all of us think about agents in terms of these 5 categories, and they're indeed different for different agents. So for example, with approachability, that's about how emotionally distant or approachable an agent is, right? And the distance end here includes agents being snarky, closed off, and often they're given in the opposition of users' willingness to engage with these agents. And then the other side, the approachable side, is agents being emotionally warm, friendly, willing to interact, like feeling more like a friend, being outgoing and chill. Another example here, this sentiment towards the user, that's about how genuine versus disingenuous an agent is towards a user. And the genuine side is this being benevolent, caring, altruistic, thoughtful, really trying to help you. And disingenuous side is this being inconsiderate, indifferent, for example, pretending, or about Siri, one of the participants said, using her sus as a defense mechanism. And so these behavioral perceptions are both structured along these 5 dimensions and are different for different agents. And then we also looked at the visual perceptions. And so we combined these visualizations into collages, and we also created a cumulative visualization for each agent. And you can see already on this slide that they are quite different for different agents. And so we again identified there 5 different themes where these differences appear. And for example, people were talking about the build, like the physical build, mainly about the height of an agent. People were talking about the age. So let's say Alexa is generally perceived to be older and Siri is perceived to be younger. They have different facial expressions, like let's say Google seems stressed and they've got a lot of stuff, and Alexa is just maybe a little bit smiling and Siri would be smiling a lot. And then they also have different clothing, right? And Siri would have this daring personality with highlighted femininity. So she would be wearing crop tops, mini skirts, heels. Google would have this stereotypically awkward persona, and Alexa would have this cozy and caring character with big sweaters, mom-like jeans, running shoes, and so on. And so the cool thing about this study was that it showed us that indeed there is something in the design of these agents that defined this very consistent structure of our perception about them. And so we found that in the design itself, it was first of all the amount of information that these agents provide and the level of details there. Also the interaction style of an agent, so whether it's prompting you back, and how responsive it is to your prompts, whether it's using jokes. And the third part there was the voice characteristics itself, right? So in this case, we can see that there are very few design aspects that then produce such a diverse perception of these agents. And so they affect both behavioral perceptions and visual perceptions of these agents. And so the main takeaway from this study and for the design is that, first of all, there is this extremely rich, socially meaningful interpretation that comes from users, interpretation of actions of these agents, right? And a lot of these interpretations are very biased. So there is a lot of social stereotyping that is happening there. But the good news is that these stereotypes and these perceptions, they're consistently dependent on particular elements of the system, on particular design, which gives us, as technology designers, a stable gateway to these perceptions as we develop voice-based artificial agents. And with that, this is the summary slide of my talk. Did I make it? I almost made it on time. So we still have about 3 minutes for talks, for questions, sorry. If you have any questions for Tony or for myself, we would be happy to answer. Thank you.
Great stuff, Anastasia. Thank you. Glad that at least one of us kept to time. So you were awesome. Kudos. So as Anastasia said, we are more than happy to answer questions for a minute or two. I do need to hop off myself at 1:15, so won't be here a whole lot longer. If just pause a bit, I just posted the link back to the INFOcon program. So following our session, there's a 15-minute break, and then the next session happens at the bottom of the hour there. So sorry, good morning, good afternoon, good evening, wherever you're coming in from. The next session will be a session called Lead from Wherever You Are, Skills for an Evolving Profession. And so that's going to be given by Miriam Burgos, Marion Philadelphia, Harris Smith, Chris Stewart, all from the University of Southern California. I'm not seeing questions, so I'm just gonna, give everybody back 2 minutes of their day. Just posted there a link to the program, my contact information, Anastasia's contact information.
Yes, except that you included there my website, which is right now outdated for a couple of years. So I actually do have a new website, which is going to be posted at the same address soon. So, but please feel free to send me an email to reach out, and I would be happy to chat.
All right. Thank you very much for attending. I hope you have a good rest of your day, everybody.
Thank you.
See you all.